what I would recommend to people doing is divide and conquer, because you have fairly complex facilities. It's easy for me to say go from the meter and find out where the thing is going, but you guys have fairly complex facilities. It can take a while. So the best way to do this energy audit is to divide your tasks. So use that energy audit and divide the task according to, best way that I found it is to your processes. So if you have 3 distinct processes in your facilities or 33 distinct processes, go through each process, find out what's input into that process, both raw material wise and the energy wise, and what's the output. And find out what can operator control in this environment. Ask them, can you control this? Because if you can't control it, there's no point in displaying it, there's no point in tracking it. So that's why that audit is the most important step. It takes time to prepare it properly, but it's worth the investment. So for each task, as I said, define these inputs and outputs. Identify the parameters that are important both for energy flow and for your business. And link those two. Link the energy to something that's important to your business within that process. Can anybody think of a reason why would you do that? You already have the data. Later on we'll talk about baselining, about what is normal, how much energy should we use. If you have the idea, if you have that historical information, now you don't have to wait another 6 months to collect the information. You already have it. You can analyze it. Secondly, you will know what time interval is important for you. There's no point in collecting information on energy every 15 seconds if all you're tracking is 8 hours worth of production. You're just making it more complex than it needs to be. And ultimately increase persistence. There has been many stories where a really strong leader has implemented energy system, then they moved on, and energy system is now sitting on the sidelines. Because there's no link between the business objectives and energy objectives. And I don't have to tell you which one is going to win every single time if there's a choice between the two. So link those two. Make sure that energy and business objectives go in the same direction. That will increase your persistence. You will not depend on one person making a decision. It will be important for everybody in the organization. So now, if you went through this energy audit, if you did step by step, either internally or externally or combination of the two, you have by now defined why are we measuring it? What's the point of measuring anything? Secondly, you will have defined what is it that you're going to measure. And that will by nature tell you where to measure it. At which time interval should you measure it? And lastly, who are we presenting these results to? Who is interested in knowing? So if you have those answered, now you can talk about actual hardware, about meat and potato of it, meters. There is no point in talking about the meters, going into details, if you haven't defined your purpose. Because you will waste a lot of time and a lot of effort and a lot of goodwill for nothing. Second part that I always keep repeating is, you do not have to be meter expert. This is no different than buying a piece of production equipment. You ask supplier, what is it that you want to get out of? So answering those things that we talked about earlier will give you the functional requirement for your meters. So you can go to any vendor that you like, or number of them, and say, these are my functional requirements. This is what I want this meter to achieve. And I can guarantee you there is a lot of them out there that are very capable vendors who will supply you a meter that you want. But that not only gives you functional requirements, what you want out of the meter, it also gives you a warranty claim. Say, I asked you for this, why that has not been done? Because very often you see somebody buying a meter, they don't know exactly what they want, so they're like, I just want a meter that's going to measure natural gas. You get it, it doesn't work, and you're like, well, it doesn't work. Well, all you told me is you want a natural gas. It measures natural gas. What else do you want? So now you don't have anything to go back to the vendor with. If you have functional requirements, you have what you want to measure, where you want to measure, how often, how precise. You have that defined. Now you can go back and you can get a real solution rather than just a meter. So speaking of natural gas metering, of course, this is one of the topics that we'll talk about here today. This applies to any energy stream that we talked about. I would encourage you to think of any energy stream in those terms. But we'll talk about a little bit more about natural gas metering right now, just because we're a natural gas company, so, you know, call us selfish. I will be the first one to tell you that it's more involved than electricity metering. It is more intrusive than the water metering, definitely. And there's 2 meter types. That's all you can essentially do today. There's an inline meter and there's insertion meter. There is such a thing as ultrasonic flow meter, but unless you have the line in hundreds of psi of pressure, you will probably not get anywhere with it. And if you do, let me know, because that's valuable information. But last I've heard, if you don't have 200 psi in your line, ultrasonic is not really going to give you anything. So you're down to, you can either cut your line and put the meter inside it, that's inline meter, or you can drill a hole in your line and put an insertion meter. Those are your choices for natural gas metering. It requires cutting your line. Requires a bypass. This is one of those things that people always forget. We used to have a meter loan program a while ago where we would lend people our regulation meters, and they would have to cut the pipe to put it in. They would do that, and we would always tell them, put the bypass in. But bypass costs money, so nobody did it. Well, guess what happens to your equipment if that meter stops working? It stops operating. So now you're down, you're downtime. For a meter, yeah, meter was for free, but how much did it cost you all this? So it requires a bypass, for sure. Therefore, that makes it a little more expensive to install. So that's why people shy away from it. However, it can be very accurate. Those are the same meters that we use for billing you. And they're not limited by pipe size. So if you have like a 1/4-inch pipe, you can put a meter in between. Question is, why would you want to measure 1/4-inch pipe? But that's a different issue. You can. The other one, insertion meter, which is not as well known, is much more flexible installation. You can usually do the hot tapping. People can hot tap into the pipeline, or if you can schedule it so it's done on your regular downtime. You do not need extra downtime. There is no bypass that's required, because if something doesn't work, you just pull it out. No big deal. Install cost, therefore, is often less than the installation alone of the inline meter. And there's drawbacks, of course, no free lunches. Accuracy is not billing grade, but is that really important? That's why you have functional requirements you work through. And pipe size is limited to 1 1/4 ID. Just because there's this insertion that goes, the tip that goes into the pipe, it's kind of hard to put it in the really small pipe. Speaking of insertion meter, my colleague Jeff Mazzi has built a nice little example here of insertion meters.
So what we have here for this demonstration is a flow bench rig that I set up. We have a blower that's going to blow air through this pipe run across the flow meter sensing tip and then out here. We also have a flow meter, and we have the box, and we are going to explain how this is all put together and give a couple pointers for what you're looking for if you're going to try to measure a gas in your industrial facility. So if you have a pipe that you'd like to measure the flow through, what you're going to need to do is you're going to need to weld a weldlet onto the pipe. You're going to have to hot tap the pipe. You can also do it when there's no flow. So for example, during a shutdown, you want to attach a ball valve here, some sort of isolation valve, so that if you ever need to take the flow meter out for maintenance, you can just close this valve and you're done with it. You don't need to worry about gas escaping. But this ball valve and weldlet will accommodate the flow meter. You're going to get the sensing tip into the flow. All this will be supplied and calibrated by the vendor of your flow meter, so you shouldn't have to worry about all this. But it will be good to know, because when you're locating the flow meter on the pipe, there's a couple rules of thumb that you want to remember. First, you want to locate the flow meter roughly 10 pipe diameters after any sort of flow obstruction. So that could be a elbow, it could be a T, it could be an orifice plate, it could be a valve, anything like that. You want to locate it 10 pipe diameters after that. You'll also want to locate it 5 pipe diameters before the next obstruction. The reason being, you want to make sure that the flow in the pipe is as laminar as possible. You don't want turbulent flow through your measurement area. It's going to give you an erroneous reading, and it's going to be very tough to pin down. So what we have here are the flow meter, we have the control box, and we have a Z3 Controls net meter Omni in a second box that we're going to use for logging and for data capture and logging